Okay, my outstanding friends, I'm going to go right to the bowels of the beast, literally. We're going to be talking about fecal matter transplants, which is the microbes, the little bacteria that live in primarily your gut, your intestines, your stomach. There are bacteria that break down the things that you eat so that you can digest them. If you don't have that bacteria there, you're not going to digest it. It's that simple. They have been finding out now, it's been going on for many years, that the fecal matter transplant, the new bacteria in the gut, does amazing things. And now they are saying that it can alleviate depression where nothing else can. Let's talk about this. And I'm going to give you a good detailed analysis of this and why it's so important you understand this. People are losing their health care today. Literally today. All of a sudden, nobody can afford it. It's a luxury item. I mean, thousands of dollars a month for health care coverage. And then a lot of people, you can't afford it. What happens? Well, go home and that's it. Have a nice day. No. We can get away from most of this stuff just by adjusting the bacteria that's in the body so that you can ingest and absorb the correct things. Get rid of irritable bowel syndrome. Almost everything appears to be influenced by the bacteria in the gut, and it's because of the enzymes that the bacteria create. We're going to go into this. Get ready. Okay, my friends, this is so important you can't believe it. We have a health crisis and it can be avoided, I'm almost certain. What you're seeing here, you see ribosome location. In bacteria, ribosomes float freely in the cytoplasm. So inside the bacteria, they're just rolling around. In our bodies, eukaryotes, ribosomes can be free in the cytoplasm, just floating anywhere they want, or attached to the endoplasmic reticulum, or found inside mitochondria and chloroplasts. I'm going to explain all of this. It's simple. All it means is if you don't have the right bacteria in your microbiome, in your gut, you will not digest your foods correctly. You will not build proteins. You will not assemble the fats the way they're supposed to be assembled. You not break down the sugars and all the other things in your body. The only thing that does anything in your body that is chemistry is done from a ribosome. The only place ribosomes come from is bacteria. You see this? Bacteria are used as factories to produce enzymes by genetically engineering them to express and secrete the desired enzyme on a large scale. Bacteria are the factories that create the ribosomes, which are the enzymes. All right, I'm going to try to go through things sort of kind of quick, and then I'm going to, at the end, go into more detail. All of these things play the part. The bacteria create the ribosomes open up and become the enzymes and proteins, which are huge molecules. Those molecules break down things, kill things. They're the enzymes that do the chemistry instantaneously. Then you have tight junctions where everything in your membranes has to be sealed well, and that's all about chemistry. You got a new layer that nobody's ever known about before, which is the interstitium, which is that layer which is literally the lymph fluids run through that layer. I mean, I'm serious. I'm not kidding you. They didn't know it was there. And lymph fluids is what keeps you healthy. This just pops up. Harvard psychiatrist says mental illness starts in your cells. Yes, it does. Exactly what I'm reporting on today. It's in your interstitial fluid. If you don't have the right ribosomes and enzymes, you don't have the right chemistry, you're going to have all kinds of problems. Mental illness is just one of them. I'm going to refer to this video I just did a month ago. And I'm going to show you here, I'm going to be showing the cells and the bacteria, the ribosomes, all of that stuff. But before I do that, I want to show you something that was a comment left by my good friend Marguerite O'Reilly, who studied ribosomes. She went to Harvard to the medical school for ribosomes, to understand how they affect the human body. And I worked with her. I went to Johns Hopkins for genomics at the same time, and we worked back and forth. And at the same time, we were trying, and we did, work with her son, who had the most extreme case of autism. Autism's a spectrum. Some of them just a little bit. Some of them just can't do anything. They can't control their nerves. They can't control their sound. There's no speech. They can't control their bowels. It's just nothing in the control environment inside their body. Why? Well, we've more or less figured it out. All right, this is the video I'm going to be referring to, but Marguerite commented on this video here, and here's what she had to say. This is Marguerite O'Reilly. She says, Roger is a true hero, how he has uncovered the mysteries of the proteins by exploring and diving deeper, giving us all the mysteries of the proteins. Proteins are enzymes, proteins, basically the same thing, amino acids, little polypeptide chains. Roger's work is so visionary and complex, many don't understand the importance, and yet this information will save our lives. It's so far advanced, only now is AI catching up. Roger has done all the work for my country, she's in Belfast, and children out of the kindness of his heart, bringing on board the friends, the wise men who never gave up on researching for children and families. Thank you so much, Marguerite, Belfast, Ireland. Love to you, Marguerite, and to John Jr. We worked with John Jr. because he was on the worst end of the spectrum on autism. Way off the charts. They wouldn't even take him into a study because they said he was unsalvageable. And they were going to put him in a locked ward, they call it over there, a locked room for the rest of his life, in a padded room, because he was uncontrollable. He couldn't speak. They didn't know what he was thinking. He was a little aggressive, I guess, and things like that. And he was 9.5 years old when we started. And now he's doing pretty good. I think he's like 16 now, something like that. This was a while we've been doing this. And I brought on board some other people, friends of mine, a triple PhD in bacterial engineering. Everything breaks down to the bacteria. Everything's in the bacteria. I'm going to show you right now. It's ultra simple. And the fecal matter transplant is nothing more than putting thousands and thousands and I mean hundreds, maybe, well, they know at least 75,000 enzymes exist right now. Every bacteria, well, not everyone, but most bacteria create an enzyme. I don't know, maybe they all do, but I know most of them do. And those enzymes are what are the catalysts in chemical processes that happen in your gut. They're never going to happen if you don't have that bacteria squirting out that ribosome to make that enzyme. Okay, and I'm not divulging any patient information or anything. I worked with Marguerite, and she is doing everything possible that she can possibly do to bring this forward and to get this accepted, as to at least be looked at as a treatment. Her son had profound autism. That's the worst you can get. And it's significant complications, all kinds of problems. They often round-the-clock support daily functioning. They can't do anything for themselves, really, in the profound autism state. And there's all kind of repetitive motion, stimming, with stimulated activity, and, you know, or just a real severe case is why they term it profound autism, level 3. We're going to have more and more of this. And the reason is the guts are becoming more and more problems with the bacteria in the guts. And there's several reasons for this. Anything that kills the bacteria in your gut, you can't make that bacteria come back well. And if the family, in the water, the air, the food, all of that stuff that comes through you. Any of that stuff can kill the bacteria in you, and every time you kill bacteria, you lose another enzyme, and then you can't break down a certain thing, and then all of a sudden, these specific enzymes, apparently for the autism, my feeling is it's related to the sheathing of all the different types of nerve fibers in the vagus nerve. The vagus nerve, the huge thing that runs up to all kinds of nerves are running together. And I think they are isolated from each other by different materials, not just by one type of coating. There's myelin sheathing, but I think there's a lot of inclusions in that myelin sheathing that are polar. This is something they haven't thought about. These are nerve impulses, and they are electrical impulses. They're electrical impulses. I don't care what anybody says. Those have to be, they're so bundled up that the only way to separate them is charge separation. Insulation, I don't think it's going to work all that well. They're just too close. So charge separation would be polarity. And that's a region I work in with the dipole electron flood theory. But all of this stuff ties together. Let's get into why you need to think about what's going on in your gut. I'm going to go back to this video that I did, this one here. And the reason I did this one was because the medical tests, the regular common medical tests that they give you, can kill your enzymes, kill your bacteria, which destroys the enzymes. What am I talking about? CAT scans, things like that. If you get a CAT scan, you're getting all kinds of radiation through your body, which will kill enzymes. Now, will it kill them all? No, but it'll kill some. It depends on how weak you are in the first place. What you need to do is resupplement them. And now, even in this latest article about the fecal matter transplant, they are talking about doing what we were talking about, is freezing for your whole life the bacteria that's in your gut when you're in good shape, and then bringing it back. They're talking about all the irritable bowel syndrome, and that's exactly what happens with kids that have autism. Almost 100% are going to have some kind of digestive disorder. And the fecal transplant intended to restore the digestive tract with healthy microbes. And they can become degraded or unbalanced with illness or use of medications, antibiotics, anything in the ecosystem. Includes bacteria, fungi, protists, and even viruses, or living little things that are in our body that do the cleanup. They kill the invaders. They break down our food. They are patrolling continuously, and they're not stupid. These things they know what they're doing, and they are very, very specific. When I show you the enzymes and so forth that they create, it's beyond the belief of the average human mind to believe that a little bacteria can be so complex, because it spits out nothing more than huge enzymes in the tiniest little ball you can imagine. You can have 1 million or more of these tiny little balls, the ones that Marguerite studied at Harvard, which is the ribosomes. You can have 1 million or more in one single human cell. All right, I have been studying these for years and years, as the fecal matter transplants, and they used to do them with a colonoscopy, then they did an oral pill and so forth, and now they're concerned that the microbes that they're putting into you could take up residence and start living where they're not supposed to live, and overcome that area that is supposed to have acidophilus, and it's got reuteri, that type of thing, and the reuteri takes over, or the Clostridium difficile, whatever it is. One of these, they all have a different name, these bacteria, and they live in certain areas, and they're supposed to populate those areas. In your small intestine, there's a certain type of chemistry that's done. In your large intestine, there's a different type, in the colon and so forth. But I had always assumed, and maybe erroneously, but I always assumed that the bacteria that was supposed to populate these areas populated them because that area was set up for that bacteria. And I believe that's true. Because, people say, oh, no, you create enzymes from your thymus, from your thyroid, from this and from that, or your spleen. Those are enzymes. They're enzymes, but they're not creating them. It's the bacteria that are inside there that are creating them. The bacteria create the enzymes. The organ is there as a factory. That's it. The organ creates nothing. It's the bacteria that does all the work in the human body. 100% is from enzymes. Nothing else can do the chemistry fast enough to make human life work. You would fall over dead within a minute or two without your enzymes. All right, this is a video I just did a month ago, the one that Marguerite commented on. I am just going to play this and cut in here and there if I need to. And I'm talking about the bacteria and the ribosomes floating freely in the cytoplasm. Here goes. Mostly they're attached inside the cells. And every cell can have millions of these ribosomes. And these are the size of the cells. That's a cell in a body, a eukaryote animal cell. Okay, now, you see this thing says ribosomes. Well, it's just pointing in it as they're all over the place. And there's millions of them, literally millions. And then you have this endoplasmic. That's one single human cell. One single human cell. Millions of these ribosomes. They float around. They don't poop. They don't eat. They're just waiting to be attacked. Well, to be triggered. And then they do their attack instantly. Reticulum right here. This is where they collect. And I think it's like the gateways to get in to the central core. Those are the ribosomes are there to protect you. Ribosomes are killing factories. They break down food. They create all the enzymes. The ribosomes create the enzymes. I'll show you this right now how it works. Very, very elegant. Okay, remember I told you that you got ribosomes, which are these little blue balls. They're just floating around here in this, what they call the cytoplasm, just the fluids that are inside the bacteria. They just float around and do whatever they want. Well, they're actually being squirted out either on demand or just continuously. I think continuously. Now, I do believe it's continuously. I watched some videos about actually watching them moving around, and they appear to be squirting them out regularly. This is the DNA that says I'm a certain type of E. coli. Now that I think about it, I'm almost certain they're squirting them out regularly, and because they're being used very quickly. And the reason I know that is because if you kill all your bacteria and from a nuclear pulse. Hi. Okay, you see this? A flagellum, which you may never have heard of, but I will explain to you exactly what it is, can spin from hundreds to over 100,000 revolutions per minute. 100,000 per minute, a flagellum. See that? This is a flagellum. They can go, Bzzz! These things can spin through the human body at rocket ship speed. Nobody's taking that into account. They're intelligent. They know where to go, and they know how to get there using their flagella. Now, they don't all have flagella, I don't think, but the ones that need to deliver things and to go pick up things have flagella, and that's how they get places. Now, cytoplasm is just a fluid. So, and it's inside of the bacteria, same as inside the human body. The cytoplasm is fluid. Just in general fluid. All right, now, then of course you got the cell wall and all of this business. The plasma membrane, everything has a membrane. 100% of your body and 100% of everything and 100% of your organs and 100% of your blood cells have membranes. all have membranes, and they are not exactly the same, but they are similar in most cases. Now, then you have the DNA, which is the bacteria's general program, and that's exactly what it is. I don't care what anybody says. DNA is a program, and it is an unbelievably sophisticated program. Inside that program, there's another program that says, I am a acidophilus, whatever it is, and I am going to program this little chunk of polypeptides, which are a chunk of little amino acids. And I'm going to program those in an exact certain order, and when it turns into a little ball, it's going to be called a ribosome. That's what Marguerite wants to study. I studied them too, but she went to Harvard. All right, this is a mud fossil, and it is in my microscope right now. And it is literally like a piece of meat, and fresh looking meat. Focus on these two dots right here. You see that? Those are the entrance and exit of the lymph fluids. They all have these. And every latch that latches a body part into the body has its own fluids. It appears to, well, I know it does, because it makes a membrane that surrounds that organ or whatever it is. This happens to be on a piece of meat. You see the texture of the meat? I'm going to show you this in a second. I mean, it's literally meat. And this white strap here that's coming down creates a triangle at the end, and it latches into the next body part. And this white stuff is all extremely tough connective tissue. Let me see if I can. So I'm doing it by hand. It's a little hard. But that's the anchor right there. And then from there it goes back and it gets real thin. I'll show you in the regular camera. Hold on. Okay, from my mud fossils, I know that every body part is latched into the body somewhere. And they're latched into with a fibrous membrane, which has actually two holes in it. Now this is a lung, and I can't really show it to you easily on this one, but you can see it comes over that little triangle looking thing. Comes over the top. That's the latch. And that's where the blood and the lymph flow to the next area in your body. They're like two separate systems. The blood is one system, the lymph is the second system. Now, I will show you, or I have shown you, this rock, which is a mud fossil. And hold on, let me home in on this here. You see that? That is it's like a piece of meat. I mean, and a very good-looking piece of meat, to be honest. Now, that latch right there, that's what we're talking about. That latch tags in right here from this body part, and then this little flap comes over. And right at the end of the flap, there's two holes. We're going to see those in the microscope. Those two holes are where the fluid from this layer and its own layer, lymph, flows. Lymph is separate from blood. All right, and I'll show you the two holes. You can see them. I'm put on the microscope. All right, there is the sample in a microscope. And here it is right here. Now that's that little triangle piece that came down here. These are the two dots. And I can see there's different. One of them has a different chemistry than the other. See how white that one is and how dark that one is? They're not really, really easy to see the difference. But I can see it. And you know, I've been studying these things a long time. And that one there on the right, I'm not sure whether that's a vein or the artery. Well, see, it's not really a vein or artery. This is lymph. Nobody knows about this. Nobody knows about these particular spots, I don't think. They think it's just as big big web. And there is a difference between the gut lymph and the rest of the body lymph relates to, you know, the viscosity of it. Well, hold on. Okay, I think I have established that there is an in and an out from every organ and every body attachment. If something anchors it to the next set of body parts, that fluid has to continue through this fluid-filled network, through these tubes. Now, my question is the lung fluids that surround the lung the same type of fluids that surround the stomach? I don't think so. I would be surprised. I'd like to see the chemistry done on this. All right, you see, this lymph is normally clear, watery sort of fluid, similar to blood plasma. The blood plasma is where everything is out of the blood and all you have is the fluid left. And this lymph is somewhat similar. However, in the stomach, or actually in the small intestine, that's the key, small intestine, has a milky white appearance due to its high fat content. And then they go through about how you break down the fats and so forth in your body. But everything is done by enzymes. So if you don't have the enzymes living in these different areas in your body, the ones in the small intestine, you're not going to break down the fats. Well, what does that do? I don't know. All right, so here we got the small intestines again. You got enzymes. Lipase breaks down the fats in that small intestine, making them small enough to be absorbed by the lacteals, which are special little organs that work with the fats, because they're kind of big globular things. Okay, my friends, I'm going to make some statements here that I believe we are missing where the immune system exists, is in the lymphatic system. And these two different little dots allow the tubes to flow into different organs and so forth. There's 200 different types of cancers. Why so many different cancers? Why isn't there one cancer attacks everything? Every organ is protected by its own fascia, which is a membrane. It coats it. And then it leaks or sends fluids in and back out through these two tubes. Medical science, I don't believe, knows about those. I'm going to show you these. I've talked to some top people and they claim there's this, they don't know about them. And this connects every organ to the next organ or into the body proper. And each area has its own rubber bag coating. It's called a membrane. All right, so you've seen the two dots that drain the fluid in and out of this membrane layer, which is very thin. It comes together right here at the latch. I'm going to bring the microscope up high so you can see the whole thing at once. All right, there's no reason to keep it in the microscope. You see all that whitish looking stuff? That's the fascia. And where it gathers at the very end here, that little latch, is what I was showing you before, and it has the two little dots in the end. You won't be able to see it here without the microscope. That is the latch that's really tough. That is a tough spot. It brings all the fascia together and it makes that little knot right there. And then the little flap comes across and latches to the next piece, which would be over here, whatever that was. And then move around together. And that's how things are held in your body. All the lungs have them, latches and so forth. I got them, I can find them in every body part where they connect. And then the rest of it is completely enclosed in basically like a rubber bag. That's what membranes are. They could completely surround this. And if you break through that, that's when you get disease and cancer. You know, before I was focused out, these are all the different types of tissue that are in your digestive system. You're absorbing all kinds of different things in different places. Lymph is just one of them. Lymph is completely separate from, well, not really. Lymph apparently carries a lot of the things that you're absorbing through your body. Now, I always thought it was the blood that was the transporter of all the nutrients in the body, but now I'm not so certain of that. This is absolutely the immune system, but does it transport nutrients as well? It might. It could very well, because there's a ton of bacteria living in there. And, well, it creates the enzymes. The enzymes are the chemistry, I don't know. They could be two completely separate things. That's where chemical business is done in the lymph, and the food business is done in the blood. Because the blood carries things. They're a metal core, and then they have what's called ligands around. There's transition metal complexes. They're very complex, and they carry things through the blood. The blood is loaded with metals. I mean loaded. It literally has almost all the metals in the blood. And these are the transporters. They have charges on them, so they can grab things and carry them. They call it ligands. Okay, here is my question. And here is something else. If you want to learn about physiology and so forth, lymphatic immune system, this is Sunny Services. Anatomy, Physiology 2. And now this is all about the lymphatic system, very, very deep and detailed. And if you look through this whole thing, this is teaching you about the lymphatic system. And I can't imagine that they don't know about this transfer from the lymphatic area through the tissues. I mean, they show it in such great detail, but they may not. They may just think, I've talked to anatomists and they don't talk about it, understanding that they move through these little tiny holes. Now, so if they did understand it, that's fine. I understand it, yes or no, it doesn't matter to me. Because what I want to know is, does this bag of fluid, this is the immune system that surrounds the lung, is that fluid identical to the fluid that surrounds your stomach and it surrounds your heart and it surrounds your liver and your kidneys and all the different things that are wrapped in their own bag? They're all wrapped in their own literal plastic bag, basically. Some of them have real heavy-duty fabric on them, like the lungs, because they have to do this all the time. And the heart has some pretty good material around it too. Anything that's moving a lot has to have something wrapping it that is flexible. What I want to know is what's in these different body parts as fluid. Now, that could, I think, easily be done at an autopsy. You know, you got to probably do it fairly quick and take out the fluid from each one of these organs and see what different types of bacteria are in there, or primarily bacteria, enzymes, whatever you want to look for. Whatever chemistry is in there is different than the other chemistry. Why? Why is it different? And is that associated to being sick? And I think it will be. All right, this is by Candela Citations, Licenses and Attributions. This is spectacularly detailed about the lymph and about critical thinking questions and about all, you know, they show it in pretty good detail. I mean, everything. And like I say, I can't believe having this much detail, they wouldn't know about those input and outputs at each one of the organs. And wherever the attachment is with the fascia, it has to flow through that stuff together. This is very, very detailed. So I have to assume they know about that. But do they know if there's different chemistry in each one of these different bags? That's the question I have. And we may need to test the fascia fluids rather than a blood test. Okay, my friends, as I have shown you, what you need to do is come up here and see this one. Common medical tests and how they might affect enzymes from good bacteria and why it matters. This is important. I think I'll give myself a thumbs up. Now, and please give me thumbs up. Try to help present this stuff. This is important stuff, and it's being overlooked because it's it's an intrusion into everybody else's realm, but this works. And I have, experimental evidence working with Marguerite. I'm going to go through another couple videos. This has to be understood. It's not being understood. So I'm going to leave it at that for today. But as I have shown you, I have evidence to support literally everything I say. I don't make false claims real quick. Now, I don't know if I showed you this before, but these are all the different layers of tissue and how they absorb. And I mean, this is very well understood now. However, this was not understood about this interstitium, which is the layer that we're talking about, the fluid-filled highway. They just figured this out a few years ago, and nobody even still understands it well. And we need to understand the tight junctions and so forth. All right, thank you. Have a sterling day. I am going to continue to report on this, and I hope Kennedy or somebody will start to work. Marguerite is doing a fabulous job over there in the United Kingdom. She's actually spoken at The Hague about this, but things take forever. All right, I love you. We need to stop this. The kids are in terrible shape from not understanding this correctly.